My name is Mariusz Postal. I invite you to the next lesson of the External Data Management toward Functional Programming course, which is part of the Programming in Practice educational path. Programming in Practice is a discipline that systematically applies engineering principles to the design, development, and implementation of algorithms, code editing, and testing. It is a segment of software engineering that includes sequential, adaptive, concurrent, real-time, and distributed programming, as well as external data management. The main goal of this lesson is to review the prerequisites needed to understand and reuse the examples that clarify the toward functional programming course topics. Since this is only a recap focused on coding system implementation, the discussion will be generic and not supported by examples. For detailed examples, consider enrolling in the Udemy course titled Programming in Practice, Information Computation. An appropriate URL has been added to the lesson resources. In this lesson, you will learn why I chose C# to prepare the examples stored in a GitHub repository. An appropriate URL has also been added to the lesson resources. Don't expect an in-depth dive, but rather a discussion on how to get started. However, I want to address your concerns and emphasize that I see the programming language as merely a tool for implementing relevant algorithms. My goal is solely to enhance your knowledge, not to fill gaps in your language skills. In any case, in the second part of the lesson, I will discuss what to do if your language skills are insufficient to participate in and benefit from the course. As usual, let's start by defining the main objectives of this lesson by defining the topics we may encounter in the context of available resources. I will try to keep the discussion general enough to be useful generally, but make it practical. We must use a selected programming language to make our activity practical. Hence, next, you will learn why I have selected C# to prepare examples that are to be explored during deploying the Programming in Practice educational path. But let me get ahead of your doubts and stress now that, in principle, the programming language is considered only a tool to write down examples. Anyway, we will also discuss a case if it is not your native and principal programming language. Again, to make our discussion about programming practical, we must distinguish between design time and runtime environments. Both are tightly coupled, but the possibility to trace the behavior of the examples is very important for programming in practice. Following that, the next step in this course is aimed at learning about the prerequisites for code execution and tracing its behavior. Don't expect a deep dive but rather a discussion addressing the question of how to get started for free. As I mentioned previously, all topics of concern are discussed in the context of examples stored in a public repository. I have selected GitHub to store the code examples. Additionally, GitHub is a perfect solution because it allows for improvement or adding new examples. Again, discussing details on how it works and how to use this platform is a good subject for an independent course. However, at least we must know how to get started, so I will limit the discussion scope for this part of the course to the selected topics only, namely, how to clone the code to the local copy and how the code is organized. Today, software is almost always developed by teams. I mean, tightly coupled contributors. Hence, you have to be prepared to work as a team member. Because of limitations, we cannot organize real teamwork, so I propose to apply community collaboration instead. In this case, the members are loosely coupled. The Programming in Practice approach is based on extended examples. The examples have been collected in the GitHub repository. GitHub is not only a storage of reusable open-source software. During this lesson, due to limitations, we cannot effectively organize real teamwork, so I will explore GitHub collaboration functionality that I believe is crucial to improving your knowledge and programming skills. I decided to use the C# language to develop the examples. So the question is, why C#? There are many reasons, but during this lesson, I will try to explain the most important ones. The used programming language may be recognized as an obstacle to understanding the examples. I believe that this obstacle can be overcome. I will also try to prove that for understanding the Programming in Practice main concepts need only the basic knowledge of the C# language. Employers seek skilled programmers who are knowledgeable in this language. Therefore, learning and teaching it is beneficial. It contains unique features that are well suited to illustrate the topics discussed. For me, The most important of this language is that it is strongly typed and object-oriented. Another reason for selecting this language is the good and easily accessible documentation. You can find it by searching the C# guide phrase on Google. From the returned results, it is easy to select the appropriate entry to get access to the documentation. For your convenience, the link is also added to this lesson resource. For years, I have been using it daily for commercial software development and student teaching. Last but I hope it is not least, it must be emphasized that it is a very modern language and is one of the fastest evolving programming languages among all, but this development is backward compatible. To get more, I have added a URL to the article titled 15 Reasons Why You Should Learn C# to the lesson resources. Check it out to get more details. Knowledge of the programming language is one of the prerequisites of this course. Hence, let's talk about the expected familiarity of the selected programming language, I mean C#. Since I know the language pretty well, it is difficult for me to anticipate the scope of knowledge that is necessary to understand all the examples. Now, I must emphasize once more that learning a language is not the goal of the Programming in Practice series. Again, this programming language is used as a concrete context that will allow illustrating the subjects discussed using very practical examples, so they can also be useful in other applications. Since I am familiar with the language, it is challenging for me to estimate the extent of knowledge required to comprehend all the examples. Now, I must emphasize once more that learning a language is not the goal of the Programming in Practice series. Again, a programming language is used as a concrete context that allows illustrating the subjects discussed using practical examples, making them also useful in other applications. I will discuss topics that I will try to illustrate with concrete examples. Working with examples requires a development environment. Generally, I will use the Community Edition of Microsoft Visual Studio as my integrated development environment, IDE. It is a free software tool that allows you to edit, build, diagnose, and publish your application. This is the basic tool I will use, so I will assume you have an entry-level understanding of it. Let's get back to Visual Studio. After cloning the repository to your local disk, there are a few options. Check out the README file in the main folder for more details about the specific solutions. You may find it more convenient to view the content on the repository landing page, where it is rendered automatically. Just navigate to the repository using an internet browser. Next, we will open an example solution. To open the solution, double-click on the selected file. For instance, here is the X-Data Management file, which opens examples designed for use during this course. Unit test projects are a crucial part of the educational path I am proposing. By design, unit tests validate the correctness and consistency of the created program. The role of the unit tests included here is slightly different. They were developed with teaching value in mind. They aim to make the examples comprehensive and enable the analysis of the behaviors of the presented code patterns. This approach serves as my silver bullet, allowing me to explore topics based on practical examples. I hope that this way, the examples remain clear and not obscured by unnecessary details required to execute them as part of a complete program. Of course, the testing and teaching roles mentioned here cannot be entirely separated. A detailed description of the unit test design and deployment will be covered in a separate course. Earlier, I promised to show how you can update your knowledge while working with examples in the Visual Studio environment. Let us assume that to understand the property injection unit test class, we need to know more about the trace event type definition. After selecting this identifier, we can use the F1 key, which, as we can see, will take us to the MSDN documentation describing this type in detail. Of course, to use the F1 key, the internet access is required. We can do the same when we need to know more about the selected language construct. This time, let's assume we're not sure what the namespace keyword means. After selecting this keyword and pressing the F1 key, after a while, in the browser, we get an open document with a C# language description. We do not always need such a detailed description as it is when using the F1 key. To access only the type declaration, we can use the context menu or the F12 key, thanks to which the expected declaration will be displayed in a separate tab. In this case, the declaration has been recreated from the net library referenced by the project, so no internet connection is needed. This documentation is created dynamically based on the metadata contained in the indicated assembly file in the reflection mechanism. Unfortunately, of course, this procedure no longer works for C# keywords. In this case, we get a message that the documentation is not available. As I mentioned previously, all topics of concern are discussed in the context of examples. The code examples must be stored somewhere in the public domain. I have selected a GitHub repository to aggregate the examples. GitHub is also a perfect solution that allows for improvement or adding new ones. Again, discussing details on how it works and how to use this platform is a good subject for an independent course. However, at least we must know how to get started, so I will limit the further discussion to the selected topics only, namely finding, cloning the repository content to the local copy, and how the content is organized. The URL of this repository is on the screen and has been added to the lesson resources. You can also find it very easily by asking Google, for example by entering a phrase "Mpostel," that's my nickname, GitHub TP. For my computer, the link to the repository is included in the first returned proposal. The next link will take you to my profile description, and a list of other repositories maintained by me. So let's use the proposed link and open the landing page of this repository. A README Markdown document is rendered on the cover page of the repository, aggregating the code samples. It opens by default and provides a general description of the content of this repository. In the See Also section, there are references to supplementary material, including a description of Visual Studio. Let's go back to the Code Examples repository homepage. To make a local copy of this repository, I propose to use this green button. Here we have an Open in Visual Studio menu entry. Depending on your browser, the behavior may be slightly different, but finally, we should get on screen the title page of Visual Studio. As a result of the magic key action on the repository page, in the text fields of this window, you should get the repository URL and a file path to the local folder where the local cache of the repository is to be created. The clone key starts copying the current content. This process takes a while, and the time needed to complete this operation depends on many factors, including the speed of the internet connection. Of course, that's not the only way to create a local copy of the repository. You can also use dedicated external tools for this purpose. Here, however, it is necessary to emphasize the difference between the cloning of the entire repository and the local copy. A local copy of the code can be obtained by selecting the Download Zip option or using the zip archive attached to the repository release. Each of these methods has its advantages and disadvantages. Allow me to point out only one of the advantages of cloning, namely, the cloning operation means that we have not only the current version of the text of the code locally, but also the history of its modifications. Thanks to this, we can choose any point in this history as a starting point for further work. For example, we can return to one of the previous versions and then branch the modification tree. Therefore, it is very important to access the right version of the code that is synchronized with an appropriate course. Here, however, it should be stressed that the code may evolve in the future. Let me emphasize again that this is not an archive but a repository. Thank you for watching. To follow me, watch or star the repository with the extended examples on GitHub. If you have questions or doubts, contact me by Gmail. com@programmingandpractice24. Let me invite you to visit Mariusz Postel's profile on C# Corner. Again, thank you for your time. I look forward to seeing you again in the next session, which will cover the main scope of the Toward Functional Programming course.